We are looking at Utme 2013 questions on differentiation. Precisely, we have two questions on differentiation in the year 2013. Now, we are looking at paper type U, and on paper type U, we have these questions as number 35 and number 36. Now, let us look at number 1. If y is equal to bracket open 2x plus 2, bracket close to power 3, find dy dx. In other words, find the derivative of this function. That is a composite function. And the second one is, if that's number 36 of 2013 paper type U, if y is equal to x sine x, find dy dx. This is a derivative of a trigonometric function. Now let us take them one by one and see how to solve it. Now, for the first one, number 36 and number 35, which is y equals to 2x plus 2 to power 3. The simple rule is to use this power, which is 3. We use it to multiply the derivative of the function inside the bracket. The function inside the bracket is 2x plus 2. So when we differentiate 2x plus 2, we have 2. So the y dx now will be equal to the power, which is 3. Now we come and multiply the derivative of the content. That is 3 times 2. Right, then we repeat the bracket again, 2x plus 2. Then to power 3 minus 1. We must subtract 1 from the old power to have a new power for the derivative. So 3 times 2 is 6. Then we have 2x plus 2 to power 3 minus 1, which is 2. So that is what we have. According to this paper type, the correct option is option B. Option B is the answer, which gave us exactly 6 into 2x plus 2 to power 2. Now, in solving this kind of problem, the basic rule is that we have y equals to function of x now to power n, then the derivative dy dx will equal to the power, which is n, times the derivative of the content of the bracket, which is f prime of x, then times the bracket, which is f of x, then to power n minus 1. So that is exactly what we applied to this question. And the original power was 3. It came forward to multiply the derivative of the content. When we differentiate the content of this bracket, we have 2. So that is 3 times 2. The power multiplying the derivative of the bracket, that is 3 times 2, which is 6. Now we repeat what we have in the bracket is 2x plus 2, but the whole power now reduces by 1 and becomes 2. So that is the simple method and the shortcut method of differentiating a problem of this nature. Then let's move on to the second question, which is number 36 of that same paper type U. This one is not a composite function, but a trigonometric function. Now, differentiating trigonometric function is also simple. We have y equals to x sine x. Now, want to differentiate this, we need to use a rule which is called product rule. Product rule is essential for differentiating problem of this nature. Our u is x and our v is sine x. Now, our du dx, when we differentiate u with respect to x, we have 1. And our dv dx is a rule that derivative of sine x is cos x. Now, from product rule, we have that if y is uv, where u is a function and v is another function, then the y dx will be u, the v, the x, plus v du dx. Simple. So this is the basis or derivative of product function. And you can see that x is a function and sine x is a function. So x is multiplying sine x. So we can use our product rule to solve problem like this. That means product rule applies to function of this kind. Now, since we have gotten our u as x and du dx as 1, our v sine x or dv dx is cos x. So we can substitute for u in the product rule formula. Now, doing that, we have our u is x, so that means the y, the x will be x, which is u, standing for u. dv dx, our dv dx is cos x, right? Then plus v, our v is sine x. Then du dx, which is 1, so times 1. So we have x cos x plus sine x. So that is our derivative. And when we look at the options that we have, that is option B, which is rearranged as sine x plus x cos x. That's all. We are looking at the solution to all the differential calculus problem in Utme question. That's university and matriculation exams of Nigerian universities and polytechnics as well as colleges of education. So we continue in in other videos we have the solution to other year problems in the subsequent videos. Thank you very much. I wish you all the best.